Hello everyone, today my friend and I are going to present about timetable and scheduling. First and foremost, mathematics is divided into two main branches, applied mathematics and pure mathematics. Discrete mathematics, a crucial component of applied mathematics, include graph theory, a fundamental topic. Graphs provide a visual representation of information and their theoretical concepts are extensively used in computer science application. Many graph theoretic problems exist, such as the shortest path problem, job sequencing problem, conditional covering problem, traveling salesman problem, and graph coloring problem. Graph coloring problem essential to solve real-life problems such as scheduling, resource allocation, traffic phasing, and task assignment. Discrete mathematics can be applied to create conference schedule by using graph theory algorithm. Graph model the conference schedule with session and top as node and conflict as edges. Discrete mathematics enable organizers to optimize their resources and improve the attendees' experience. Now, we move on to abstract. Discrete mathematics is crucial in the creation of timetable and schedule for daily application, such as school, transportation, and conferences. The goal to organize activity efficiently while minimizing the conflict. Graph theory and algorithm can be used to model schedule as a graph and find the optimal solution. The use of discrete mathematics in scheduling ensure that all activities are well attended and optimize the use of available resource. It improves the quality of schedule and makes sure that there's no activity that are overlooked.
Hi, my name is NABILAH and we talk about the history of our timetable and schedule. The development of calendar by ancient civilizations such as the Babylonian and Egyptians marked the beginning of timetabling and scheduling. However, it was the emergence of mass transportation networks in the 19th century, such as railway, that led to the current notions and timetabling and scheduling. The invention of computers and mathematical optimizations approach in the early 20th century further advanced scheduling and timetabling. Today, they are crucial in many industries and continue to evolve with the development of new technologies. Standardized time zones established by American and Canadian railroads in the 1883 eliminated the need for local time and made scheduling more effective. With more than 93,000 miles of track constructed by 1818, timetabling and scheduling play a crucial role in coordinating train movement. That's all from me for history. Thank you! I will explain about the literature review of our topic. Discrete mathematics has proven to be useful in optimizing timetables and schedule in various fields. Several research papers have discussed the applications of discrete maths in timetabling problems, including graph theory application to timetabling problem, a review, which provides an overview to the use of graph theory in creating optimal timetables. A survey of timetabling problems and algorithm discusses about the different techniques for solving timetabling problems, including constraint programming and multi-heuristic. A hybrid genetic algorithm for solving cost timetabling problem presents about a hybrid genetic algorithm for solving cost timetabling problems, while a new approach to school timetabling using constraint logic programming discusses about the use of constraint logic programming in creating optimal school timetables. Overall, these papers demonstrate the wide range of application for discrete mathematics in timetable and scheduling problems and show how algorithm and technique can be used to create efficient schedules in various fields.
Scheduling theory is a subfield of operations, research, and computer science that studies scheduling issues and create techniques to address them. There are numerous scholars that have contributed in this field's development. Four of them include George Danzig, John von Neumann, Carl Adam Petrie, and Richard Bellmans. The first one, John Danzig, is credited with developing linear programming, which uses simplex algorithm to solve optimization problems in scheduling. The next one, John von Neumann's work on game theory, and the minimax theorem can be used to solve scheduling problems where multiple agents need to coordinate their actions. The third one is called Adam Petrie. He developed Petrie nets, a mathematical modeling tool that can be used to simulate movement of tokens through a system, making it useful for scheduling issues. And the last one is Richard Bellman's. Richard Bellman's contribute to dynamic programming helps solve scheduling issues involving sequential decision making, such as airplane takeoff and landing times. Bellman also proposed the curse of dimensionality, which refers to the difficulty of resolving optimization issues as the number of variables increases. Next, we will go to formula and graph. The first one is formula related to this topic is G equivalent to VE, where the vertex set V is ABC, FI, PS, and the edge set E is AB, AC, AI, BF, CI, CP, FI, FS, and PS. Points or nodes are alternative terms used to refer to vertices. An edge in a graph is a line that connects vertices. Edges are typically represented by an unordered pair of two vertices, where E is equivalent to in bracket X, Y. In figure 1, the edges of G are in bracket AB, AC, AI, BF, CI, CP, FI, FS, and PS. We will go to the next figure, where a graph G, where G is equivalent to in bracket VE, where V is V1, V2 until Vn is called a cycle. It's denoted by Cn if only Vi and Vi plus 1 is all an element of E, where I is bigger or equal to 1 and smaller or equal to n minus 1, and in bracket V1, Vn is an element of E. A path of with 7 vertices is shown in figure 2. The third figure is a path that explores every vertex and every edge of a graph G precisely once defined and earlier wrote in that graph. If a path visits each node in the network precisely once, it is said to be a Hamilton path, which is undirected or directed graph. If a Hamilton route creates a cycle, it is referred to as a Hamilton circuit. A tree is a linked graph without any cycles. Every pair of points in a tree is connected by a different path. Next is figure 6, an undirected simple graph. If every pair of G vertices are nearby, then G equivalent to in bracket VE is said to be complete. Kn stands for a whole graph with n vertices, which is for every in bracket UV is an element of V. The fifth figure is, if the vertex set V can be divided into two non-empty subsets, V1 and V2, so that there is no edge between any two vertices in either V1 or V2. Every vertex in V1 is adjacent to every vertex in V2. A simple undirected graph where G equivalent to in bracket VE is said to be a complete bipartite graph. KPQ stands for a full bipartite graph with P plus Q vertices. The next figure, figure 6, shows that a graph without direction, if there is a 1-to-1 correspondence between a vertex set V and a set of intervals I on the real line R, such that two vertices are near in G if and only if their corresponding interval has non-empty intersection, then G equivalent to VE is referred to as an interval graph. And finally, figure 7. As there are 9 intervals in figure 7, there are also 9 vertices designated as V1 until V9. Also, we observe that the intervals I1 and I2 overlap with a non-empty edge, indicating that there is an edge connecting vertices V1 and V2. There is also an edge between the vertices V1 and V2, since the intervals I1 and I3 also overlap in a non-empty manner. Nevertheless, since I1 and I4 do not share a piece, there is no edge connecting vertices V1 and V4.
Hi, I'm Mahirah. I will talk about the significance of timetables and scheduling in our daily life. From transportation to healthcare, education to transport, and manufacturing, scheduling is a crucial aspect of our daily life that we might often overlook. Firstly, let's look at transportation. Timetables are essential for managing public transportation systems, improving efficiency, and ensuring vehicle runs on time. For instance, a timetable that guarantees buses arrive every 10 minutes can increase public transport usage. In Kuala Lumpur, the MRT has a useful timetable accessible through My Rapid Pulse for passengers commuting in an urban area. Secondly, timetable helps Schools and universities manage classes, exams, and activities. Student benefits from having a structured education through timetable, which outlines subject names, class times, and location. Exam timetables are particularly important for early preparation. Thirdly, scheduling is vital in healthcare to manage appointments, surgeries, and medical procedures. It ensures patients are given specific time slot and help reduce waiting time. Next, scheduling is also crucial for managing tournaments, competition, and events in sports. It ensures games run on time and athletes have adequate rest between matches. A scheduling system can consider the number of players, matches, and court availability, minimizing disruption and delays. Finally, managing production processes and optimizing resources usage and ensuring timely delivery of product is essential for manufacturing industry. A scheduling system considers factors such as raw material availability, capacity, and production stage timing that will ensure correct order and specification without delay or issues. In conclusion, timetables and scheduling have significant usage in various aspects of our daily life. They help us stay organized, optimize resources, and improve efficiency, that ultimately leading to a better performance. Next, I will talk about the benefits of implementing scheduling and resources optimization system in various industries. The system can help business increase productivity, efficiency, and optimize resources use, ultimately leading to a better outcome. Firstly, scheduling system can decrease wait times and speed up a service delivery, especially in healthcare. By ensuring that resources are used wisely and services are delivered quickly and effectively, business can improve the quality of service offered, result in improved customer satisfaction, loyalty, and overall business performance. Secondly, resources optimization system can reduce waste and increase profitability by minimizing downtime and boosting efficiency in manufacturing and transportation. By considering factors such as raw material availability, production capacity, and production stage timing, business can ensure that correct order and specifications are met without delay or issue, ultimately leading to cost saving and better business performance. Lastly, these systems are useful resources for business in various factors. They help business stay organized, optimize resources, and improve efficiency, ultimately leading to a better outcome, of course. In conclusion, scheduling and resources optimization system can bring significant benefits to business across various industries. By implementing this system, business can improve their productivity, efficiency, and overall business performance, ultimately leading to a better outcomes, of course, for both business and their customers.
Moving on to the disadvantage in timetable and schedule. So actually there are a lot of disadvantage in timetable and schedule. First is that it have a tendency to be rigid and inflexible, as timetable are made closely to adhere and it is very challenging to make adjustment. Second is that it is complex, as it is challenging to comprehend and utilize efficiently. Third is that it actually costs money, as we need to invest in technology which can be considerably cost burden. The fourth point is that it have a resistance to change, as it is challenging to successfully install a new scheduling system, as it will change the workflow and process. Last but not least is that the accuracy depends on the data provided, and every data mistake will result in scheduling mistakes. Moving on to the conclusion part, application of discrete mathematics in timetable and scheduling is important in organizing daily activity, such as to make school schedules and transportation schedules. It is also used to provide formal framework for modeling and solving problems. Next is that discrete mathematics can create optimal schedules that meet the desired criteria. Last but not least is that it can improve the organization and management of daily life. Thank you.